Wetland ecosystems are essential for filtering water alongside providing resources and habitat for wildlife. While the warm days of summer allow for impressive visuals and sounds in the wetlands, the snow-filled winters allow for a time of rest. These ecosystems depend on seasonal changes to function properly. This is by nature's design. Wetlands Seasons of Change.
Wetlands respond to climate and weather. They are indicators of climate and weather. They have vegetation that is flood resistant and drought resistant. And so that vegetation can look differently depending on whether there's been a lot of rainfall events or little to no rainfall events.
Wetlands are naturally very dynamic ecosystems, and they're defined by their variation. But a lot of the variation that occurs in wetlands is seasonal and predictable. And so the organisms that live there are adapted to cope with these variable changes. So for example, hydrology or water level, the plants that we find in wetlands, the reason they're different than the plants we find other places is because they're tolerant of having their roots saturated for long periods of time, and they can also withstand periods of drought. A lot of folks don't realize, but a lot of our terrestrial insects, they have aquatic larvae, and so they start their life forms in wetlands. And so they're going through different developmental stages at the different times of the year, and so they're not necessarily, the wetland's not necessarily preparing for those, but those organisms have to be prepared for that change and be able to cope with that variation.
Also, one thing about wetlands, and I teach wetland ecology and restoration, and one of the things that a point we make in the class is, as wetland is one of the few ecosystems, if you're standing in a wetland, you might not always know you're standing in a wetland. If you're standing in a lake or a river, you probably know where you're at. And in wetlands, because they're not always wet, they're particularly vulnerable at different times of the year for removal. And I think one thing that folks around Ohio can do is during dry periods to not remove wetland vegetation. So a lot of times of the year, it's not possible to do that. You have these saturated soils that kind of make them a little bit off limits, but other times of the year they dry out. And so often that vegetation is removed, especially if we think about around the Great Lakes. A lot of that natural wetland vegetation is removed, sometimes just for aesthetic value. But those plants serve important functions like nutrient removal, also important stopover nursery habitat for migrating waterfowl, those kinds of things.
Seasonal indicators such as dry and wet periods allow researchers to see how wetlands function at different times of the year. Since a wetland undergoes noticeable changes from one season to the next, these indicators are vital in assessing functionality. Take the wetland waking from its winter slumber, for example.
Spring is just like bam, it's like the arrivals department at an airport, where it's just like all this traffic is coming in, all these birds that are migrating north from the tropics, birds that have flown from Argentina and Chile are coming up to these wetlands. And the ducks spent their winters in Costa Rica, and they're winging it, and they're coming through, and they are looking for those seeds, those food that haven't got picked off in the fall, because it was kind of like this little gold mine just sitting there all winter long for the most part, because things were sleepy. And then, so it's just this cacophony of sounds. It's just like, as the wetland comes alive, so much wildlife wakes up, shows up, and it also even sets up territories. These migrating birds I mentioned, birds like secretive marsh birds like rails. You get the big tall white egrets, the bitterns coming in, and it's just the strangest sounds. You could be there at dawn or dusk, and you hear these sounds that kind of give you an idea why marshes and bogs and swamps got a bad rap 200 years ago, because there's all these crazy sounds, and if you didn't know 200 years ago, you'd just think these places are possessed or something like that, or whatever the myth was, sort of thing. So yeah, springtime is this an amazing time.
Some ways that wetland plants adapt to the spring to summer transition when water levels are typically starting to lower in wetlands, as they have these deep root systems that stretch very far throughout the wetland system. So if a particular area is drying out, those roots might reach several feet to where the water is still at. So those plants can still gather water to help them survive through the more drier months. And wetland plants also have rhizomes, which are very interconnected root systems that are very good at holding water. So once the system starts to dry out, they're still holding water in those roots, so they can persist throughout the dry seasons and months.
The spring is a really important time for a lot of the other organisms that are part of the wetland food web. So actually, algae are an underappreciated component of wetland food webs. So because the plants are the part of a wetland that you see, whether they're standing dead in the fall or the winter or in the summer when they're, quite tall, but they're not very nutritious source of food, and it'd be a little bit analogous to us eating celery, whereas some of the microbial community are more nutritious, and we're finding, our research is showing that they're an important part, a food source for aquatic larvae, so things like dragonfly larvae, snails, and those are really important for a lot of the waterfowl that are having their little chicks in the wetland in the spring.
Following the springtime blooms, the wetland is on full display once summer comes around. Peak blooms of certain plants lend visual appeal, while their fruits give sustenance to wildlife. Although warmer temperatures create drier wetlands, these environments lend a hand in providing habitat.
In the summertime, wetlands can be very hot. Water levels are typically a little bit lower than they have been in the spring, winter, and fall. But still, the plant species have become very full. A lot of times in wetlands in the summertime, it's hard to see open water because the vegetation is so thick. Water levels may have dropped a bit, but still supporting a lot of life, both underwater and on top of the water. You might have ducks that are using that particular wetland to raise a brood, or dragonflies that are utilizing the wetlands to feed on insects and other things. Wetlands are very alive in the summer with lots of life.
It's just this color of green. All the plants are cranking out seeds. They're all flowering. They're all blooming, hopefully getting pollinated. And then all the birds that we're singing, they've all set up their territories. They're all raising young at that point. So they're just like those videos where you see the baby bird going back and forth, or the mom going back to the nest. It's this thing, like kind of that thing. And then by late summer, things are starting to like chillax a little bit, where it's just sort of like, okay, I did this, and all right, time to kind of enjoy and just, yeah.
Crisp coolness meets the summer warmth as fall arrives. This is the time for later blooms to form, while the wetland itself prepares for the colder season. The leaves on surrounding trees start to transition colors and drop to the ground, providing insulation for the wetland throughout the season.
In the fall, it's an interesting time because wetlands are a little different than other ecosystems in that they sort of have a dieback period. We refer to that as senescence, where the plants turn brown. If it's a swamp, you can see these bright colors. But it's sort of a time of change. Wetlands are ecosystems that have both wet and dry periods. The fall time often is dry period where water tables drop below the surface. Work that we're interested in is related to nutrient cycling that happens during this period. And some of the nutrients that were sequestered by the wetland earlier in the season are now released back into the environment.
In the fall, wetland ecosystems are very alive, while the plant material might be turning from green to brown, and it's starting to look a little bit more dormant. Animal species are thriving, but also different types of water birds like shorebirds, great blue herons, bald eagles, and osprey are often seen migrating through these wetland areas as they're working their way down to southern climates. So they're very alive on the surface with the waterfowl and the water birds. Underneath, the fish and the amphibians are starting to calm down and prepare for hibernation. But really an interesting time in the fall to be out at a wetland and observe what's happening and to see the birds.
Wetlands start to quiet down in the fall, with migratory birds heading south and plants going dormant to prepare for the cold temperatures of winter. To the eye, it may not seem like much is happening in a wintertime wetland, but there are indicators such as air bubbles to show there is life below the ice.
If you're an aspiring dendrologist, which is a scientist that studies trees, and you're observing a forested wetland in the winter, it's a great time to see how those species, the forms of those species without their foliage. So you can get a better understanding of their bark, of their branches, of the twigs. And depending on what time in the winter, if we're closer to spring, you might be able to see the buds that lead to our blooms later in the season.
So in Northeast Ohio, especially like along the lake, when we get the lake effect storms, anybody who's grown up here, did you know that Northeast Ohio is the coldest and wettest part of Ohio? Especially like Lake County and Ashtabula County, northern Geauga County. They get more rainfall and colder temps than any other place in the state of Ohio. So we call it kind of locally the monsoon season, or the lake effect snows when they come. And so if you've gotten that snow in the wintertime, it puts a blanket on top of the wetlands. And lo and behold, no surprise, Northeast Ohio has more wetlands now than anywhere else in the state of Ohio. It's the highest density of wetlands because of those lake effect snows in many ways. It's kind of neat. So in the wintertime, the wetlands they look kind of sleepy, they're kind of dormant, but they're not really. At the surface, you've got some snow down. The plants are just chilling, but underground or under the snow, depending on how cold it is, especially if you've got like a nice blanket of snow, life goes on. It's a little sleepier. If it gets really cold, okay, it's gonna kind of slow down, but maybe by midday, mice are moving around, or meadow voles in the wetland. If it's just moist soil, they can get around. Some of them, we have star-nosed moles. Those guys swim underwater. They're a mole that swims underwater, and they're bopping around. Turtles are kind of estivating in the wintertime. They're we might call it hibernating, where they're just kind of slowly hanging out. Frogs, they're doing things inside them physiologically where they move water out of their organs so they don't freeze in the organ. That when ice freezes, it shreds. So there's all these tips and tricks that turtles and reptiles and amphibians do in winter. The microscopic critters, the aquatic inverts, are just kind of still doing their own thing. Maybe by February, things get really cold. They start to go dormant. But then again, by March, the daylight levels start to really, in the first day of spring is March 20th. So wetlands just kind of have that winter lull. Let's just put it that way.
The seasonal indicators that occur are necessary for the wetland to continue thriving. It is crucial that seasons continue to change throughout the year so wetlands can perform functions that benefit other plant and wildlife species.
Yeah, wetlands are really interesting in that they really need all types of weather. A lot of folks think wetlands should be wet all the time. They really shouldn't be wet all the time. There should be times when they are very dry. That's important for the seed bank and for the mudflat annual vegetative species that need really dry conditions to germinate and then produce seed and then put that seed back into the seed bank. And if you have wet conditions for a very, very long time, you don't give those species a chance to reproduce. And the thing about wetlands is that they're incredibly diverse. So having different types of weather is actually very good for wetlands, and those species that rely on wetlands, like waterfowl, amphibians, and mammals, they need those diverse weather patterns, but also diverse vegetative communities that persist because those weather patterns are important to them.
So really, when we talk about wetlands, and wetland function. And we're often talking about hydrology because water prevents the movement of oxygen through wetland soils. And so if you have prolonged drought, maybe a wetland wouldn't normally dry out completely. If that happens, oxygen moves into the soils and you have carbon that's been stored over time being released back to the atmosphere.
You can also have periods of drought that are so extreme. So climate change is making something that's already naturally variable, but it's taking all those to the extreme. And so you have organisms that are adapted to cope with a little bit of variation, a little bit of drought, but then prolonged drought can actually have really negative consequences. Some organisms can't keep up with the extreme variation, and so they're not able to either survive or rebound after a really long drought. And those kinds of intense disturbances tend to weaken the ecosystem health and allow invasives to move in if either extreme goes on for too long.
Seasonal changes are important for the functionality of wetlands. When the climate becomes extreme and unpredictable, the wetland may not be prepared for this variability and will lose some of its essential functions. When the wetland is in a vulnerable state trying to acclimate, it allows dangers into the ecosystem. Invasive species will move into the wetlands, choking the native species out. Consistent extreme weather patterns are damaging not only to the wetland ecosystem, but all ecosystems.
I mean, we have weather patterns, we have a climate, and we have seasonal weather patterns. Like I mentioned, that monsoon season, sort of the lake effect snows. So every year, over thousands of years, the last several thousand especially, we have a pretty stabilized climate. And what keeps you and I alive is the climate, but there are extremes that will take you and I out of the gene pool. Too hot, like 98 degrees is our body temp, but 104 degrees, I'm dead. I can't, you know what I mean? So just that little Goldilocks zone of 6 degrees. So it's the same with wildlife too, and plants and animals. So in a changing climate, you start messing with that weather pattern on the long term, and you get events. We call these bioclimatic variables, sort of like the hot is hot, the cold is cold, the dry is dry, and the wet is wet. Those four kind of are, you want to be somewhere in the middle in that Goldilocks zone, right? You know, so you mess with that climate, and you start to have species that can't handle those extremes.
It goes back to this regularity, averages, natural cycles that are in balance. With climate change, we see anomalies in those systems. And so a wetland of a certain size depression, we can assume, if it's a wetland of a certain size depression, a hole in the ground, we can assume from its edges how much water will fill it up, the volume of water in that wetland, if it's a vernal pool in the spring, for instance. If you introduced variables like climate change, you might get more water than the edges of that depression suggest, or you might get significantly less water than the edges of that depression suggest. And that's not to say that there isn't extreme variability from season to season. That is also a part of why we use averages to understand something like precipitation events. But with climate change, that variability is taken to an extreme. And in many instances, we don't know how our wetland systems are going to respond to anomalies that have never occurred before. We can predict and attempt to model, but we can't say with absolute confidence what might be the result of those extreme events.
So climate change can very much reduce wetlands on the landscape. With increasing temperatures, we get an increase in evaporation, and the dominant feature that defines wetlands, even the ones that seem like they're dry, is the presence of water at some time during the year. And so increased temperatures and increased evaporation can remove that water signature. And sometimes wetlands even naturally have a very short period of time when they're saturated, for example. So if we shorten that period of time, we can eventually remove those characteristics. If the wetlands dry out, invasive species move in. We can have what we refer to as a phase change, where you move from one self-replicating ecosystem to a different self-replicating ecosystem.
Wetlands act as a carbon sink, or anything that absorbs more carbon than it releases when it comes to climate change. A healthy atmosphere is a direct result from a wetland's ability to store carbon in its soils. When climate change begins altering wetlands by losing more water frequently and for longer periods of time, the soil starts to release carbon back into the air. This alteration is damaging to the wetland's ability to maintain native species.
So with warmer temperatures, we are seeing the influx of invasive species that did not necessarily impact Northeast Ohio, that historically have impacted more southern areas, southern states, south of Ohio. Because temperatures are getting warmer, those species are able to invade farther and farther north because we are not having the colder winters that we used to have. And so that risk is the potential to degrade more wetland habitat through invasive species takeover, right? Invasive species colonize an area and they cannot be outcompeted by other native species. And once they get in, it's very hard to kind of fend them off and to destroy them. There's a lot of management required to help keep invasive species at bay. Here at Western Reserve Land Conservancy, we spend a lot of time and money trying to reduce and eliminate invasive species. So in terms of our management and how we want to protect and conserve these really high quality wetlands, we don't want to have to fight against more invasive species in the future. And as the temperatures warm, we're certainly at risk of having more and more invaders coming farther and farther north.
The health of Ohio's wetlands has been improving. The H2 Ohio program has done a good job of trying to promote wetland restoration, creating or building new wetlands to try to replace those that have been removed, and also just educating individuals on trying to create sort of vegetated buffers to protect these ecosystems, what we have left.
And a lot of the work that we do in wetland science, the next step in wetland science is to both manage the wetlands and also to restore them. And so what we do is all the basic research that goes into informing how to best manage and also restore wetlands. And again, through the H2 Ohio program, thousands of wetlands have been restored. And it's one of the unique areas, I think, across the country where wetlands are actually growing on the landscape.
Local communities can support wetland education through so many ways. Being educated about wetlands is maybe the most important thing, right? We've been talking as humans about wetlands and how they cause malaria and they're bad places to go. There's no ecological function, there's no societal function of wetlands, which is just not true. We rely on them for so many things. So being educated on why they're important, what they can provide for your local community, or how they're sequestering carbon, how they're storing floodwater, how they're reducing sediment nutrients. I think education of wetlands is really, really important in this day and age.
Wetlands need our help. We got them in this trouble in the first place, where we've changed the inputs coming in, the salts coming in, and the nitrogen's coming in, and then the speed of the water coming in with all our impervious surfaces, all our rooftop, blacktop. So we've got now water roaring into these systems that never used to. It's like we're creating, with all our rooftop, blacktop, 100-year of storm events, like every big rainfall kind of a thing. And so we have kind of death by 8 billion paper cuts kind of a thing, where we're chipping away at that diversity. And so we have to be really mindful of our every impact on them. And so wetlands need your help.
The future of wetlands is unpredictable, due in part to the ever-changing climate. Humans can make sure these ecosystems are sustained to continue their vital functions. Over 90% of wetlands in Ohio have been lost. Less water filtration and exposed soil pose a risk for other ecosystems. When a wetland is adapting to extreme weather, invasive species are able to move in and take over native species. This is particularly damaging since wetlands function the way they do because of those native species. Organizations and researchers are fighting for the survival of wetlands in the ecosystem. You have the ability to help wetlands as well, through planting native species to educating others on the benefits of wetlands. There is hope that the kidneys of the landscape remain by nature's design.